All right, we are going to start in on section 2.1, which is all about coordinate system. So first we're going to kind of remind ourselves, if you have a group of ordered pairs and we want to plot the points, so we have 2, 3, -4, and 1, and 0, 2. So if we want to plot these points on a graph, this tells me the x value, so I'd go out 2 units. This tells me the y value 3, so I'd go up 3 units. And I just put a dot there on my graph to indicate that's where the point 2, 3 came from. -4, 1, so we'd go 4 units to the left. And then +1 is my y value, so I'd go up 1 unit. That would be the point there. And x value 0, y value 2. X value 0 is on the y-axis. The y value 2 would fall right here. And then this would be those points plotted. So hopefully that's a review for y'all. We're going to be focusing mainly in this section on distance formula and midpoint formula. So the distance formula, we'll say the distance between points, and we're going to label them P, x1, y1, and Q, x2, y2, is given by, we'll say distance between P and Q, or distance, between P and Q. Our book uses P and R for some reason, but we'll use P and Q. We'll say it's going to be x2 minus x1 squared plus y2 minus y1 squared, and that's our distance formula. So we're going to use a distance formula to solve a problem first, and then we'll do a couple examples with that. And after that, we'll talk about midpoint formula, and that's most of the section right there. So for this example, I want to find the distance between points give us 1, 7, and the point -3, 2. So that's what I want to do. So we're going to use our distance formula. I'm going to call this the x1, y1 coordinates, and I'll call the second point they gave us x2, y2. It really kind of doesn't matter which points you call the x1, y1 or the x2, y2. You get the same answer either way. So we'll do x2 is -3 minus x1 is 1 squared plus y2 is 2 minus y1 is 7 squared. So let's see what we got here. This will equal square root of -4 squared plus -5 squared. So that will equal the square root of 16 plus 25, which, let's see here, that's going to equal the square root of 41. And as far as I know, that doesn't turn into anything nicer. So that is the distance between those 2 points. So that's our answer. So next up, what we want to do is they're going to give us 3 points, and they're going to say, are these 3 points vertices of a right triangle? So this is going to be example 3 in your online textbook that came with my math lab. So we want to say our points, they give us M, which is -2 and 5. They give us N, which is 12 and 3. And they give us Q, which is 10 and -11. Are these points vertices of a right triangle? So how we figure this out is we're going to find the distances between the points. and then see if they satisfy the equation a squared plus b squared equals c squared. So I basically need to use the distance formula 3 times. I got to find the distance between points M and N, the distance between points N and Q, and I need to find the distance between points M and Q. So I need to find all of those distances based on what they gave us there. So I'm just going to set these all up at once and then go through and solve them, and then we'll see, do the distances satisfy a squared plus b squared equals c squared. So we'll set that up and then see if that works out. So I'm going to have m be my 1 coordinates and n be my 2 coordinates. So I get x2, which is 12, minus x1, which is negative 2 squared, plus y2, which will be 3, minus y1, which is 5 squared, square root of that. Then n is going to be my 1 coordinates and q will be my 2 coordinates. So I'll get x2, which is 10, minus x1, which is 12 squared, plus y2, which will be negative 11, minus y1, which y1 will be 3 squared, square root of that. So this was the x2, that's x1, this is y2, that's y1, and in the first one here, this was x2, that was x1, this was y2, that was y1. So now m is the 1 coordinates, q is the 2 coordinates, so 10 will be x2, negative 2 will be x1. So we get 10 minus a negative 2 squared, plus y2 will be negative 11, and y1 will be 5. So y2 is negative 11 minus y1, which is 5 squared, square root of that whole thing equals, let's see here. The first one there is going to be 14 squared. So we need to see what's 14 squared. That is 196. So this is square root of 196 plus 3 minus 5 is negative 2. Negative 2 squared is 4. So that is square root of 200. Okay, this is negative 2 squared, which is 4, plus, that's negative 14 squared, which is 196. So the second one is also square root of 200. The last one is 12 squared, which is square root of 144, plus negative 16 squared, which I think that's 256. And we add those together, and we get square root of 400. So to see if these satisfy the Pythagorean theorem, a and b have to be the smaller lengths. So we'll say a and b, we're going to try those there. C needs to be the longer length. And then when we plug in to get a squared plus b squared equals c squared, we'll get square root of 200 squared plus square root of 200 squared equals square root of 400 squared. Trying to see, are these equal? We're not sure they actually are. Well, the square cancels the square root, so we get 200, plus the square cancels the square root, so we get 200 equals 400. So that checks out. So yes, these distances satisfy the Pythagorean theorem. So in this case, yes, the points are vertices of a right triangle. Okay, so that wraps up that one. They're going to have us do a second problem that will be very similar. We're going to be asked, are a collection of points collinear, which means that they all follow along a straight line. So this is example 4 from your textbook. So we're going to say are points P, which is negative 1, 5, Q, which will be 2, negative 4, and R, which will be 4, negative 10. So are these points collinear? So what collinear means is, do they follow along a straight line? So are all three of these points right along a straight line? And how you check that is you look at the first distance between look at one of the smaller distances between the 2 points. Look at the next smaller distance between the 2 points and see if when you add those 2 smaller distances together, is that the same as the longest distance? If they're all in a straight line, then these 2 smaller distances add up to the larger distance. So we want to say like smaller distance smaller distance 1 plus smaller distance 2 does that equal, when you add them together, does that equal the longer distance? So we're going to get our distances, all three of our distance equations, figure out those distances, figure out which 2 are the smaller distances. We'll add them together and compare it to the longer distance, and if the sum of the 2 smaller distances is the longer distance, then they're collinear. If it's something else, then they're not. So we're going to look at the distance between P and Q. We'll look at the distance between Q and R, and we'll look at the distance between P and R. So these will be our problems. So okay, P is the 1 coordinates, Q is the 2 coordinates, so I get x2, which is 2, minus x1, which is negative 1 squared, plus y2, which is negative 4, minus y1, which is 5. Oops. So it's y2 is negative 4, minus y1, which is 5 squared, square root of that. Then we're going to get Q is the 1 coordinates, R is the 2 coordinates, so x2 would be 4, minus x1 is 2, squared, plus y2 is negative 10, minus y1, which is negative 4, squared. And then P will be the 1 coordinates, R will be the 2 coordinates. So I get 4 minus negative 1 squared, plus y2 is negative 10, minus y1, which is 5 squared, square root of that. And we'll total up and see what these are. See, that's 3 squared, which is 9, plus that's negative 9 squared, which is 81. So we have the square root of 90 here, which that's square root of 9 times square root of 10. Square root of 9 is 3. So that's 3 square roots of 10. Here I got 2 squared, which is 4, plus, okay, let's see, that's positive 4, negative 10, so it's a negative 6 squared is 36. So that's square root of 40. Square root of 4 is 2, square root of 10 stays square root of 10. Down here I got 5 squared, which is square root of 25, plus, see here, negative 5 minus 10, that's negative 15. So negative 15 squared is 225. So that's going to be the square root of 250, which is the square root of 25 times the square root of 10. Square root of 25 is 5. Square root of 10, square root of 10. So to check this, we say, all right, the smaller values, 2 square roots of 10 plus 3 square roots of 10. We want to see what does that equal. Well, 2 square roots of 10 plus 3 square roots of 10 equals 5 square roots of 10. And 5 square roots of 10 is the longer distance. So these add up to be the longer distance, which means the 2 shorter distances add up to the longer distance. So the points all fall in the same line. So in this case, yes, the points are collinear. Okay. So next we get the formula for a midpoint. So we say a line segment with endpoints P of x1, y1 and Q of x2, y2 has midpoint x1 plus x2 divided by 2, y1 plus y2 divided by 2. This is our midpoint formula. So we'll do a couple of quick calculations with the midpoint formula. And then we have a little bit of plotting, and then that's basically the section. So let's do an example. We want to find the midpoint of a line segment with endpoints at P, we'll say 1, 4, and Q of negative 3, 11. Okay. So to use the midpoint formula, we basically add the x values together, 1 plus negative 3, we divide it by 2, and then we do 4 plus 1, which are the y, 4 plus 11, which are the y values, we add those together and cut it in half. So I simplify it down. 1 plus negative 3 is negative 2 over 2. And then 4 plus 11 is 15 over 2. And if we simplify that, negative 2 over 2 is negative 1. 15 halves doesn't turn into anything nicer. And we get our midpoint is this. So that one's not too bad. You just add the two x coordinates together, divide them by 2. Add the two y coordinates together, divide it by 2. And then simplify any of the fractions or any of the additions or any of that stuff down, and that gets you your answer. Okay, so next up. So we say, okay, suppose a line segment has one endpoint at x value 3, y value 5, and a midpoint at x value negative 4, y value negative 2. We want to find the other endpoint. Okay, so here's how we're going to do this. If we remember, our equation is x1 plus x2 over 2, y1 plus y2 over 2. This is the equation that tells us the midpoint. So we know one endpoint is at 3 and 5. So 3 is going to plug in for x1, and 5 will plug in for y1. So now what we have is 3 plus x2, x2 is the unknown endpoint, over 2, and 5 plus y2, the unknown y value of the endpoint, over 2. Now, this is supposed to be the x value of the midpoint, and this is supposed to be the y value of the midpoint. So this right here, this whole bit here, this is x value of midpoint, and then this whole bit right here, that's the y value of the midpoint. Well, they told us the x value of the midpoint is negative 4, and the y value of the midpoint is negative 2. So what that means is this part right here is equal to negative 4, and that part right there is equal to negative 2. So that's going to generate two equations we can solve. When we get the x2 and the y2 solved for, we'll know our missing endpoint. So we get 3 plus x2 over 2. That's the x value of the midpoint. They told us in the problem the x value of the midpoint is negative 4. So we can use that to solve for x2. and we get 5 plus y2 over 2. They told us in the problem that is equal to negative 2, the y value of the midpoint. So we're going to start out, we're going to multiply by 2 to get the 2's out of here. So this will be 3 plus x2 equals negative 8. I'll subtract the 3 on over. And I get x2 equals 8. Negative 8 take away 3 is negative 11. So here we multiply by 2's to get the 2 out of down here. We'll say 5 plus y equals negative 4. I will subtract 5 across. So I'll get y, whoops, I dropped my, it's y2. So y2 is negative 9. So my ordered pair is going to be negative 11 and negative 9. That is the missing endpoint. So this right here is the missing endpoint. X2, Y2. Okay, so that is that problem. Next we got a couple of things where they're going to give us equations and they want us to find a couple of quick solutions. And then they want us to give us a few equations and they want us to make a sketch. So for this part here, we'll say for each equation, find 3 ordered pairs. So we'll have part A is y equals 4x minus 1. And part B will have x equals square root of y minus 1. Okay. So for this one, there's no real square roots or anything kind of tricky, so I'm just going to choose some easy to work with x's. So I'll say x is 0, x is 1, and x is 2. And I'll let the equation tell me what y value those generate. So I'm going to be replacing x in this equation with each of these numbers. So when I put 0 in there, 4 times 0 is nothing. Then you subtract 1. Nothing minus 1 is negative 1. So that's my first ordered pair. Then I put 1 in. 4 times 1 is 4. 4 take away 1 is 3. And I put 2 in. 4 times 2 is 8. 8 take away 1 is 7. So I got my 3 ordered pairs for the first bit there. On this one, I'm going to work on this one a little bit. Choose my values a little bit carefully. This time x is by itself, so I'm going to be kind of choosing values for y and plugging the y values in. And I want to choose the y values. I want to make the square root easy to evaluate. So you don't have to do this. Like you can keep the square root as whatever, but for me, I think it's easier if I choose y so that if I subtract 1, it's a perfect square. So like if y is 5, when I subtract 1, it's 4, and square root of 4 is easy to do. If y is 10, 10 minus 1 is 9, square root of 9 is easy. If y is 17, 17 minus 1 is 16, square root of 16 is easy. So if y is 5, 5 minus 1 is 4, square root of 4 is 2. If y is 10, 10 minus 1 is 9, square root of 9 is 3. If y is 17, 17 minus 1 is 16, square root of 16 is 4. And so I generated my solutions, or I generated ordered pairs that are solutions using that idea. Okay, final bit here wants us to graph some problems, and then that's going to wrap it up for section 1.1. So that'll be the last little bits. So they want us to, for this is example 8 in the textbook, they want us to graph following things. Part A, y equals 4x minus 1. Part B, x equals square root of y minus 1. And part C, y equals x squared minus 4. Now, if you're familiar with some of these equations, you can kind of use a bit of information to know kind of what the lines are going to look like. So we know This is y equals mx plus b form, so we know that's going to be some sort of straight line. This we're not really sure of. We don't really know what that graph's going to look like. This one here, it's x squared minus 4. We know it's going to be some kind of parabola. And so why we do that is just, if we know roughly what sort of shape the graph's going to make, it's going to be easier for us to graph it. For these, what I like to do is we choose x, we choose y. We're going to choose x to be 0. That'll tell me when x is 0, that'll tell me the y-intercept. We're going to choose y to be 0. That'll tell me the x-intercept. And then we'll use some other easy to work with x values. And then hopefully once we piece that together, we'll have the graph. So if I put 0 in for x, if x is 0, 4 times 0 is nothing. Nothing minus 1 is negative 1. When I put 0 in for y, I'm going to actually need to solve this because it's sort of an equation that's hard to think about. Scoot the negative 1 across as a positive 1. We'll divide the 4. And we'll get 1/4 is the x value that pairs up with y equals 0. So to get that, I set y equal to 0. Said what x makes that true. When I put 1 in for x, 4 times 1 is 4. 4 take away 1 is 3. When I put negative 1 in for x, 4 times negative 1 is negative 4. Minus 1 is negative 5. So here are our points. We know it's supposed to be some sort of straight line. So we have x is there, 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. So we say, all right, at negative 1, we are negative 5. At positive 1, we're at 3. At 0, we're at negative 1. So when x is 0, y is negative 1. And when x is a fourth, y is 0. So that gives us these points. And we can see, we know that this is supposed to be a line. And the points all connect through to make a straight line. Well, just pretend my line's better than I drew it, but we get kind of this for our graph. So that's the first one. Next one here, we're going to say x generate y. We want to find the, just kidding, we want 0 for the x to find the y-intercept. We want y to equal 0 to find the x-intercept. We'll take a couple easy to work with numbers, and then maybe we'll take a couple more because we don't know what this graph's supposed to look like. So if x is 0, if I put 0 in here, we say square root of what y value makes 0? Well, y would have to be 1, so 1 minus 1 was 0. If I put 0 in for y, I get an imaginary back, which I can't graph, so I'm just going to say like not available or not applicable. So we don't want imaginaries. Let's see. Okay, this time I chose some x's here. If I put 1 in here, I have to think what y value, when I subtract 1 from it, gives me 1. So that would be 2. 2 minus 1 is 1. Square root of 1 will give me x equals 1. If I say when is x negative 1, can I get a negative 1 for an x? Square root will only give me back positive numbers and 0, so I can't get back a negative 1. To get a couple more points, I'm going to use kind of easy to work with y's. So I'll use like y value 5. 5 minus 1 is 4. Square root of 4 is 2. And I'll use 10. 10 minus 1 is 9. Square root of 9 is 3. So here we got a bunch of points we can plot. Some of them didn't make it through. They didn't turn into anything that's going to work out. So let's see here. I got x value 0, y value 1. Then we had not available for the x-intercept, so this thing never hits the x-axis. When x is 1, y is 2. Okay. When x is negative 1, doesn't exist. When x is 2, y is 5. And when x is 3, y is 10. So it looks like we're generating kind of half a parabola shape here. So we'll say that's, as far as we can get, that's going to be what that graph looks like. Now for this one here, we know it's going to generate a parabola. We say, all right, let's look at x, let's look at y. Let's let x be 0, then y be 0, then take a couple easy to work with x values. So if x is 0, 0 squared minus 4 says y is negative 4. If y is 0, I get the equation 0 equals x squared minus 4. You'll add the 4 across and get 4 is x squared. To get rid of the square, you'll take plus minus square root. Plus or minus square root of 4 is plus or minus 2. So for y equals 0, we kind of generate two solutions, positive 2 and negative 2. Then we'll look at negative 1. Negative 1 squared is positive 1. 1 take away 4 is negative 3. Then we'll take positive 1. 1 squared is 1. 1 minus 4 is negative 3. We know that this is going to be a parabola, so it's going to be some sort of U shape. We don't really know much more than that. So let's plot our points and see what sort of shape it's going to make. So x value 0, y value negative 4. X value positive 2, y value 0. X value negative 2, y value 0. X value negative 1, y value negative 3. And x value positive 1, y value negative 3. And we get our sort of parabola shape. It's going to be something like that. So that basically finishes up section 2.1. Stop there and get 2.2 in a little while.